To learn more about binary trees, we are going to implement a fun little game using them. Here, let me show you the result. Okay, the same tool I was using before to house all my examples. Hey, oops, I can type today. So, we're going to play Guess an Animal. Please think of an animal, and it'll ask yes and no questions. Are you a mammal? Let's say yes. Are you bigger than a cat? My guess is a kangaroo, am I right? We'll say no. So, what am I? A dog. So, typically yes, no question is, do I bark? And the answer to that will be yes. So now when we play again, we've extended our database. Say yes again. I mean, yes. Do you bark? Yes. My guess is a dog. Yes. So there we go. So now we can also add things on the other side. Are you a mammal? No. Do you live underwater? Trout. Am I right? No. Shark. Can I eat you? Okay. Yes. And so forth. So now when we go, we can find it again. We'll say no. Do you live underwater? Yes. Can I eat you? Yes. My guess is shark. Okay, so that's the basics of the game. Now we're going to talk about how we would go about implementing it. The reason it's a tree is because the knowledge is represented in a tree-like structure. Okay, in other words, each decision leads to two branches. So it's a binary tree. So to build out our binary tree,
I didn't get that. Could you try again?
First we're going to build our binary tree, and to begin with, we're going to create a node. A node is obviously a piece of the tree, and also could be the root of the tree as well, or a subtree. So here we go. Basically, we're going to create a node with a piece of data, because we're going to make it generic, and a pointer to the left subtree, and a pointer to the right subtree. And then here we've got auxiliary notions, methods like set right, get right, and then we have like is leaf. Basically, a node is considered a leaf if its left and right subtrees are empty. Okay, then we have is interior node, which is basically any node that's not a leaf. Okay, so let's so there's our basic definition of a tree node. Let's look at our definition of a binary tree. Here, a binary tree has a root, and we just have a method get and set root. So now let's look at our implementation. So here, we've got our binary tree demo, and the first thing it does comes along and print instructions, and then it's going to set the root by calling set instructions, or set up tree. What we're going to do is preload this tree with some information. So we've got our root and our left question and right question, and basically we create a node to the tree, assign it to null pointers on each side, and then we're going to start adding. We're going to create a node with our left question, and for that we'll set its left node to a new node with an animal as its answer, and another one with the right with its animal as its answer. And what you might notice then is and then we'll set this whole tree to the left tree. What you might notice here is that all the animals are on leaf nodes, and all the questions are on interior nodes. So this will give us, this will set up our initial tree. And so now when we go to play our game, we started our current node. While it's not a leaf, we say this query just gets input to say, to display the question, etc. And if our query returns a yes or no, true or false, it will go to the left. Okay? I mean, if it returns a yes, we'll go to the left. If right, no, it'll go to the right. It will then make a guess at the current spot, and it'll keep doing that until we get to a leaf node. If we see that it's what we ask the question is, are you right? And if we are not right, we're going to learn the current node. Here, what we basically do is we're going to set up strings for the guessed animal, correct animal, and a new question. So here, we're going to get what the new question is. What the new animal is, right? Then we're going to get a new yes or no question, right? We're going to set the current node's data to the question, and then we're going to, and here we will add the appropriate new animals and such to the left side or right side as appropriate. And that about does it for us. Pretty simple, pretty straightforward. Basically, it's showing you the power of a tree to organize your information.